Okay, we're going to go over two problems here asking us for the area of an oblique triangle. This is a triangle that is not a right angle triangle. So your old formulas for the area of a triangle that you learned in middle school will probably not work here. We're going to have to use the new formula we went over in class. And I'll just state it here very quickly for this first one. Area equals 1/2 AB sine of C. Okay, now what that refers to is if I have a triangle, I'm just going to draw something like this. Okay, this is my angle C, right there, C degrees, and I have two sides, A and B. So you multiply the two sides together, you multiply it by the sine of the angle, multiply it by 1/2, and that's your area. Okay, so let's just plug in the numbers here and see what we get. In this problem, it is 1/2 times 36 miles times 22 miles times the sine of 77 degrees. Okay, so make sure your calculator is in degrees, otherwise this is getting all messed up. 1/2 times 36 times 22 times sine of 77, and I get this. I get area equals 385.85. Okay, and you can check your calculator on this problem that I just did to make sure you're punching everything in right. This problem says to round it to the nearest one decimal place, so you can do that if you like. You don't have to. It just means if you're going to be inaccurate, make sure you're at least this accurate. Okay, you have to at least have one decimal of accuracy. So there we go. And if you want, right, this is going to be miles squared since the length squared miles. So the next problem is similar to that, but we have a twist. We're looking for an angle included by two sides. In other words, the angle between A and B. On that triangle image over here, let me grab this guy. I'm going to use this guy again. Okay, down here. So I'm looking for this angle C, but I'm not sure whether that picture that I just drew is accurate or whether it's a picture like this. Could be, this is my angle C. Okay, I tried to draw these lengths so they have the same length to them. If you take a look at that area that I just boxed in and compare it to this area, they might actually be pretty close to each other. They might be equal, because you can have a very big angle and a skinny triangle, or you can have a small angle and more of a fat triangle, and they could work out to have the same area. So we need to talk about how to deal with that. But first, let's just work through our formula. Area equals 1/2 AB sine of C. Okay, so we plug in what we know. I know the area is 42 centimeters squared. My formula says 1/2 times 5 is one side, and the other side is 45. Okay, so my picture is terrible, actually. These sides are very different from each other. And sine C. So now I'm just going to do some rearrangements here. 5 times 45 is kind of a big number. Okay, that's not bad. So if I rearrange this a little bit, I get 84 equals 225 times sine C. I multiplied each side by 2 to get rid of the 1/2, right? That thing over there. Okay, and now I divide 84 by 225, and that's equal to sine C. And now I'm going to do the inverse sine, or the arc sine. Inverse sine of 84 over 225 equals C, my angle. Notice that I did not turn 84 over 225 into a decimal, because if I did that, here's what happens. You turn it into a decimal, it's an ugly decimal, so maybe it goes on for a while. I mean, maybe it doesn't, but maybe it does. And if you have a decimal that goes on for a while, you are going to round it. And as soon as you round it, and you're not done with that problem yet, you're making an error. And maybe it's a small error, maybe it's a big error. But generally, you should not round until you get to the end of the problem. Okay, I get C equals 21.9. I'm just going to round it to 2 decimals, 92 degrees. See, I rounded it at the end. That's the appropriate time to round things. Now, that's obviously an acute angle. And this problem is saying, well, what about the obtuse angle? There might be a flat-ish triangle like this guy that I drew, where it has the same exact area. We don't know which one we're talking about. So I have to do another option, and I'm just going to call this C with a little hat over it just to make it clear this is not quite the same. That's going to be 180 degrees minus the first one, 21.92 degrees. Okay, So that is going to be equal to, let's see, 180 minus my answer is 158.08 degrees. Okay, so these are my two answers. That one's the obtuse angle. This is the acute angle. Notice I didn't give you much background on why that 180 minus angle trick worked. That's past units. We've been over that before. I don't want to lengthen this video, but that's how you handle acute versus obtuse when you're doing inverse sine.